Hi, everybody. Thank you for coming. My name is Anupama Pradhan. I'm a senior technology architect at HCSC. And with me, I have Jeff Cherng, who's a pivotal engineer. Today, we are going to talk about automating Geode testing and also CICD for Geode. So while in the talk, we may interchange the name Geode with Gemfire, because that's how we started. We started with Gemfire. It's now Geode. So if you hear us say Gemfire, it's the same thing as Geode. So before we continue with that talk, I want to give special thanks to Tim Tasling and David Walden. I think he's here somewhere. I can't see anybody, but he's maybe here. So special thanks to them. For this session, we had to create the demo, and they helped us a lot in getting the demo up and running and setting up in the cloud, so we don't have to use our company infrastructure to get this presentation out. Something about my company, I work for a healthcare service corporation. We are a health insurance company operating Blue Cross Blue Shield plans in 5 states: Illinois, New Mexico, Texas, Oklahoma, and Montana. Our purpose is to do everything for our members in sickness and health. We have a big IT organization. We have about 2,000 employees. We have a good IT spend. And we recently did a transformation with partnering with Pivotal Labs. Went into XP methodology and are doing pair programming and getting our applications out in the market at much faster rate. So let's talk about what is CI/CD. So as a developer, you pull down your code, you do your work, you do your testing, everything looks good. But you really don't know how it interacts or affects the actual code base, because you're not the only one who's working on the code. There's a team of developers who are working on the code. So you want to make sure that whatever changes you're doing are not impacting others, and you want to see that quickly. You don't want to be deep going, making your changes, and then when it's time to merge, you realize, oh, this really doesn't work, and now I have to spend a lot of another time to get the merging through. So continuous integration is a practice of making sure and testing your code with the code base and making sure you're getting that quick feedback. So that's very good. You run through your test cases with the full code base and everything looks good. But when you're testing that, it's typically you're testing through your unit testing or your mock integration testing. You're really not testing with the environment and the dependencies that your applications are working with. So that's where your CD portion of it comes in. It's a continuous deployment. You want to be able to push it automatically to a server environment where it can integrate with the dependent systems, and you can run your test, and you can get that feedback right away, and help you improve your code, make sure you're not breaking your dependencies and things like that. So this is how a typical CI/CD pipeline would look like. A lot of places, when you look at, like if you do Google on CD, it's synonymous. People talk about continuous deployment. People talk about continuous delivery. So continuous delivery is the next step further. So once I have my deployments automated, I can run my smoke test, and then if everything looks good, I have all tested code, it's ready for production, then why wait for pushing into production? I would want to push it straight to production. So that's where that continuous delivery comes in place. But for this particular session, we are just going to stick with continuous deployment. So we'll talk about continuous integration, the automating of testing, and then how I push my code onto the server environment. So let's talk about, I don't want to do that manually. So let's talk about what tools, automation tools that we can use. So we are using Concourse. So Concourse is a tool by Pivotal for doing CI/CD. Things that stood out for us to use Concourse was, as a developer, we like writing code. And Concourse is expressed in code. You can version it. You can transport it. So if I'm running on one server and the server crashes, I can take that code and deploy it on another server, and it still runs the same way. I don't have to make any changes. The tasks that you have in your pipeline, they run in an isolated environment with concourse. So every time when it runs, you get dependable results. Like, for example, when you do Maven build. So Maven build brings down your dependencies and puts it into your local Maven install. So a lot of times when you're running your builds locally, the dependency is already there. It may not pull it down again. So you don't realize that it may have been broken because you don't have the latest dependency in place. With this one, because it's running in an isolated state, it always pulling down all the new dependencies again, so you know for sure it's working with the right set of code, and it's giving you the result that that your code is working with. We can also visualize it. So with Concourse, your pipeline is visual, and which we'll show you in our demo, that you can see how the pipeline is working. You can see the green boxes for each task. And if something breaks, it turns red. So it's visually, you can see it. You can have your build monitors up on the screen as you're working. You can have a pictorial view of how it looks. So it's really nice. Gives you a quick feedback. I don't have to log in someplace to see. I can have it on my build monitor. And finally, the main thing that we looked at, is integration with other systems. So it's good to use one tool, but you want to use the tool right. You don't want to use a lot of tools. So Concourse does a very good job with the continuous integration delivery, but when we are using Geode, which is not running on a platform. It's running outside the PaaS platform. So it's running on bare metal. So we had to do the server configuration. We had to deploy the code onto the server. So it would be nice to use the right tool, and Ansible really works in that. It helps doing, it's like a Unix-like tool, and it really works well when you're deploying provisioning software, doing a multi-server cluster deployments. It really is very good. So it's all about using the right tool for the right thing. And for the demo, we are actually running our stuff in the cloud. So Terraform is a tool that we picked, which helps with the cloud provisioning. So for our session today, we are not going to go deep dive into Terraform. We're going to just stick with Concourse and Ansible. So before we go into the code and walk through it, I would like to just talk about some of the concepts so that when he talks about this, you know what those terms mean. So let's take a small portion of that pipeline and see what we have to do. So the first thing in my pipeline is I want to build my code. So that's like a task that I want to do. So it's a task. So task is a basic unit of work that you would want to perform in your pipeline. When you're doing something, like when you want to do a build, it needs an input. You need what you're building. What is the code that is? So it needs to work with the resources. So resources are something that form your input and output for a task. And then a job actually configures your task. So it tells you what your resources are, what is the task that you need to perform, and when it gets triggered. So what is your execution criteria? So that's what a job gives. And then a pipeline is orchestration of those jobs. So you can orchestrate multiple jobs to create your full pipeline. And here's an example of how so Concourse is all written in YAML. It's an example of how task.yaml looks like. And I'm not going to dive deep because that's what we're going to talk about when we go into the code. And this is how the pipeline looks. So we have like the resources defined and the jobs defined, and then the trigger criteria and the parameters that it uses. A little more about Ansible. So it's just like Concourse has tasks, Ansible also has tasks. So they are the basic components that you would use to do your deployments and things like that. So like if I want to do an OS update, you would run a yum command. So that would be a Ansible component. So roles are something where you can take multiple components together to form a common task. So it helps you build your reusable modules that you can use across different pipelines or playbooks. So like how Concourse has pipelines, Ansible, they call it playbooks. It's similar. It orchestrates your roles or tasks together to form your operation. So there's a pictorial view. So Ansible works on a node, so they call it as a node. It can run on your server, run on a desktop. So in Concourse, it actually runs in that container that's executing. It has a host inventory file, so it basically you give which servers you want to work with, and then Jeff will talk a little bit more about that. And then the playbook is what you're executing. Then it does an SSH struts trusted SSH onto the server and does the deployment and the configuration on it. So here's an example of task.yaml. It's running a yum command, which is an Ansible task. And it's saying, I'm going to start. So I don't care, all packages, just update all my packages. The state, it says, Ansible works with states. So it's saying, update it to the latest state. A little more about how the playbook looks like, and we'll dive deeper into what exactly it does. So for example, for a demo today, we are looking at an example. This is a customer order service. So we have the client, the REST controller is running as an app instance, and they're running in PCF. And since we are not running our Gemfire in PCF, we are actually running it in the AWS cloud. So from here, I will give it to Jeff. Thank you,
Anu. So at this moment of time, we're going to look at the pipeline that for this particular demo that we're putting in place. Traditionally, Gemfire has been considered really hard to operate against with. Because Gemfire is a cluster, there are many nodes involved, and when operator need to perform tasks against those Gemfire clusters, if it's manual operations that you have to get into each node and perform whatever the operator have to do, such as backup, restores, start and stopping the servers and stuff like that, it can be error prone and take a lot of times. So the ideas of the CICD pipeline today we're going to focus on is how to simplify that process from operator perspective. And also from the developers, as we start to write in the code and start to deploy the applications, how can we have the CI/CD pipeline to be able to do the deployment of the code in a non-disruptive way? As in, I want to make sure my cluster is running all the time, it's always available. If we think about like 99.99 availabilities, and the cluster is still up and running, the PCF application is still running without being interrupted through the deployment. So the pipeline we have in here try to focus on both sides of the world. We want to be able to focus on the ops and also the developers. So this is a very simple concourse pipeline that's taking care of the basic foundations. So first of all, let's look at the ops operator. So all those green boxes that you see here is the jobs, as Anu mentions. So those are the jobs that be able to perform the tasks. And it can be complicated tasks, such as, let's say, I want to do OS update. So behind the scene, because it's a no downtime operation, I need to perform operating system update, and I need to reboot the VM. And when I reboot the VM, I need to reboot the VM one server at a time to ensure my Gemfire cluster is not being disruptive. Same thing as the Gemfire update. I want to be able to update my Gemfire binaries. And I cannot just shut down my entire cluster. I need to do one server at a time and changing the binaries. So the jobs will be able to orchestrating some complex operation behind the scenes. And for this one job that we have here, something called provisioning. The provisioning is, the purpose is once you have a VMs, so Gemfire cluster involves many nodes. You're going to have the node that is responsible for locators. You're also going to have node responsible for server. And so the provision task or provision job is really responsible for once you have clean VM that's been given to you or given to the development team or operation team, you can use these jobs, be able to set up your Gemfire cluster, be able to install the JDK, be able to install the Gemfire binaries, and be able to set up the basic Gemfire configuration and deploy the code and bring up the cluster. And also, if just in case, either it's operator or developer get onto the node and did some manual operations and cause the cluster to become snowflaked. And you can actually rerun these provision jobs and be able to, it will reset entire cluster into its predefined state. So those are the jobs that's very good for day two operations. Let's say you have Gemfire cluster, it's already up and running, and we already want to be able to serve your customer applications. And we want to be able to do day two operations, and those are being automated that any operator will just be able to come in here and work on it. So we can look at the jobs. So concourse job from the UI perspective, you can actually click into the job and be able to look at the history of things that's been run, if they are successful or not. And you also be able to look at the output of the operations and tasks that's been processed. So this is one of the examples that all the things has been happening behind the scenes to perform a Gemfile update, which is upgrade. So I'm going to do a deep, because there's a lot of stuff that's been happening for the code base. Because of the time constraint perspective, I'm just going to pick some of the interesting jobs, and we're going to have a deep dive into it and show you what's the concourse code look like and what the Ansible code looks like. So we want to look at the Gemfile update. To me, it's very interesting. The Gemfile update jobs taking an input called the Gemfile versions. So this is the resource that Anu was mentioned about. Resource for a concourse, it means the input or output for a particular job you can operating against with. So we have an input resource that contain a Gemfile versions, where right now we have two different number of versions. One is 9.1.1, one is 9.1.0. So if you look at the actual jobs, when it was last executed, let me shrink this a little bit. Can we still see? Yep. So you can see that when the last time it was run, the Gemfile version that has been applied to the cluster is 9.1.0. And the cluster is already up and running. So we can take a look at the Gemfile cluster and see how it looks like. So we have two locators. And two nodes. So as you can see, the Gemfire installed on this machine is Gemfire 9.1.0. We just want to make that confirmations. And also before we start to run, before we actually run the jobs, there's something I do want to level set about the default construction that we have to make this pipeline to work proper. So our Gemfire setup, we try to break apart on where the things is actually installed and configured. Because only if you separate things out into a proper place, that's when you can make a change to the things that, on how you want to apply and be able to do rolling restart or rolling back without causing catastrophic failure. So first of all, for the Gemfile installation directory, we try to install that installation, Gemfile binary installation under the OPT directory. And then we try to create symlink to whatever the version of Gemfire that we installed under the OPT Gemfire. So this will always be static, but point to the different versions of Gemfire that's actually being installed. Then the actual application gets deployed. We want to make sure that application actually gets deployed is in different directory on where the Gemfire is actually being installed. So that way, if we just wipe out the Gemfire binary installation directory, we are not touching the app, and we can just bounce the app up right away. So Gemfire application you can think about is jars, like Gemfire functions or Gemfire listeners. You want to put into a deploy directory that you can do a deployment. And so we, just by following the Linux file system hierarchy standard, we try to put under user Gemfire app directory name. And also for the logs and stats files, those are generated by your applications. And sometimes we want to keep them, we want to put into a right place, and we want to be able to roll. So when your log files start to increase, the stats files start to grow, we want to roll it, and we are not going to cause a disk space problem. So we try to put it under var Gemfire app directory name. Then the actual data, because if you have your Gemfire cluster to configure to be persistent, and the data is actually going to be stored in the file system, we want to make sure that this file system or directory is actually available at a place where you can mount different files so you can grow that file, the file system, just in case your data size start to grow. And especially in a virtualized environment, let's say if your VM crashed and that VM become irrecoverable, at least this you can maintain your mount place and remount to a brand new image. Right? So we have this directory structure laid out, very clear, and then just follow the Linux file system hierarchy standard. And with that being said, we can look at get it back to gfish, and we can try to connect to make sure that our cluster is actually up and running. So we have two locators and two servers running Gemfire 9.1.0. So traditionally, if as an operator, if you want to do a Gemfire upgrade, I actually have to SSH to every server just like I did. And I probably have to install the binary, have to copy the file, and then I have to change the symlink, all those manually. But we have that done in the pipeline, and I just want to run this pipeline by manually trigger it. So now, as you can see, taking an input parameter of 9.1.1, and it's going to take time to install it, and doing rolling restart behind the scene. So I'm just going to let it run, and we can actually start to look at the code. And we can circle back to the result after we look at the code. So this is the concourse pipeline, as Anu mentioned. It can take in resources. You can define the resource. So resources is something, think about like GitHub, something that can store artifact or file system or stuff like that. Something as input, you can take that input and be able to take the value in there and do process against it and push into output. So you can think about like we have some kind of Docker image that be able to run certain jobs. And this Docker image is the input resources. We can have Git, right? And then we can also have CF. The Cloud Foundry component is also as an input resources where you can push the app to it. Then we also have Maven repository that can also be acting as an input resources because any artifact gets built, we can pull it out, and you can try to deploy into the PCF, or you can deploy into the Gemfire cluster directly. So let's just skip all the way to the actual Gemfire update. So Gemfire update, actually, we try to configure it into a group, a job group that's called DevOps. So the reason we want to configure these jobs into a DevOps is because we want, our pipeline does many things, is capable of doing many things, such as OS updates, such as Gemfire updates, such as deploying the code. We want to group all those things together, and we want to make sure that at any given time, there's only one job running. Because it is possible that maybe someone triggers the OS update while the server is doing rolling restart, and another person actually starts to trigger Gemfire update or server deployment, which is already in process doing update, rolling restart. We want to make sure that it's not having a conflict operation at the same time. So we configure a server group, have all the jobs that it should be grouped together and want to have a way of controlling if it's running serial or parallel, want to group them together. And over here you can say, oh, I only want to run one job at a time. So the plan is actually defining what's the input, the resource, the input and output that's relevant to this particular job. So we're going to grab some worker image, Docker image for the concourse worker. We're going to use that to run the Ansible Playbook. And we're going to pull some code. And then we're going to be able to grab the Gemfire versions as an input. Then we have a task over here, a very simple task. It's basically doing the classic cluster Gemfire update. So just FYI, our pipeline, our original code, we have another one that's over here that's doing much more because our pipeline not only capable of doing the traditional gfish deployment, we're also able to do a boot cluster deployment. It's just the way of how servers start is different. For example, Spring Boot app that when you deploy, when you want to make the change to take effect, you have to restart the Java process. But for the classic cluster application where you use gfish or cluster configuration to do the deployment, you can actually just use hot deploy. So certain things like Gemfire functions, you can just do hot deploy without the need to bounce the server. But for this session perspective, we just want to focus on the cluster configurations type of cluster, Gemfire cluster. So this is a task that's basically we are telling this task, say we are going to use one Docker image. This particular Docker image already has a Maven configuration set up. Also is capable of running the Ansible command. Also is capable of running gfish command. So this is a very specialized Docker image that can be run by Concourse. And then we're going to say please execute this particular task and be able to pass in the additional environment variables into the task. So because we are running this concourse, this particular pipeline on AWS, so we want to be able to pass the SSH key to it, stuff like that. And so also like cluster type, because our playbook is reusable, can hit against the boot app, boot cluster or classic cluster, so we want to give a very specific instructions. So the task of doing Gemfile update is over here. So we have task.yaml. This task.yaml is the basic definitions of what this task is supposed to do. So for example, this, we are running against, it is really Linux-related, it's a Linux-based task. And here's are the parameters that we're going to take from the input, but we're also going to give some kind of default. So of course, this default doesn't mean anything, but you can give some kind of default and also can take the input parameter from your actual job. Then those are the resource for the input. We care about the versions. We're going to have some kind of Git code that we're going to run against with. So the task run can be simple. It can be regular Linux command, but it can also point to a more complicated shell script to run things. So this is the shell script that will be executed by the actual task. So really just set up the environment for this particular task, grab the actual source code for certain things we want to run, which is like Ansible Playbook, and then set up the actual Gemfire versions as variables within the bash shell script. And then over here is actually running the playbook, the Ansible Playbook. So we can keep this shell script as simple as possible because concourse is really not meant to do the configuration management. We want Ansible to, Ansible or even if you can think about like Puppet or Chef, let the right tool to do the right thing. Especially for configuration management. Concourse is not best because it can be too complicated. We can write the script if we want to, but let the right tool to do the right thing. So we're going to ask you the Ansible Playbook by passing the Gemfire version to it. So let's look at the Ansible Playbook. So we have one Ansible Playbook called Rolling Gemfire Update. This is a very simple playbook, but before we get into the actual playbook, let's talk about some fundamental setup of Ansible. So Ansible, like Anu said, we can create a lot of reusable modules. We can have playbook, we can have task. So those are the components that can be run against various numbers of hosts. But we do not want to have those host informations hard-coded inside of your task or a playbook and so on and so forth. We want to be able to run those playbook against any given number of the host or any given number of the server. Imagine today we only have 2 locators and 2 servers. Tomorrow we might want to run the exact same playbook against maybe 30-node cluster. So over here, Ansible has the concept of something called host file. So in the host file, you can actually, this is where you want to define the actual host name that you want your playbook to be able to hit to. So we have a server group. So over here, you can think about those are the host group. Something we're going to label it to call GF locators. So those are the actual host name. And also the variables assigned to that particular host. It is very specific to that host. And then we'll also have another host. So we have two locators and 2 servers. Here are the server group of the server. And combining with the locator and server, we're actually getting a cluster. So here's another group that actually contains all 4 hosts. So this is how you set up your host files. And then similarly, we have another host file for the boot app. So those are the VMs that's related for the boot cluster. Just to show you the concept, you can have multiple host files and can be able to apply the playbook against different host files. So we're not going to run against those host files. We're just going to run against the classic cluster. So apparently my VPN got timed out. I need to connect to my VPN. Oh, one good thing is that we are actually running those things on the cloud. So that's one good thing. Let me see. That even though my local machines gets disconnected, our pipeline is still running on AWS. Our concourse is running on AWS. So we will still be able to get back to the server and to verify if our Gemfire being updated. Awesome. I didn't have to do anything, and pipeline just update my Gemfire to 9.1.1. So anyway, let's get back to the code. So this is the host file that we got covered. And then for the host file, you can have actually the variables assigned to different type of server group, because locator might need something very specific to the server type, such as locator port. And if you want to use enable cluster configuration on that. And then for the server, here's the port is 40404. And then we'll also have other variables that's very specific to this entire cluster. Right? So we have some default values, and those default values can be overwritten, such as these Gemfire versions, that when you run the playbook, it can override this. So this is just some snippet of what things is behind the scene. So now we can actually looking at the Gemfire update. So now we know what are the server groups. So really, this playbook is meant for the Gemfire cluster, for the entire cluster. Not just for the locator, not just for the server, but for the entire cluster. So when we run the playbook by passing the proper host file to it, it will look for every server that's belong to that group, or running in all the tasks against all the hosts defined in the host file. And then the remote user really means is what are the user is going to be used to actually SSH to the host to running operations. So Ansible is really about having a node contain all the necessary instructions or SSH to all the hosts automatically and run the command. And become true is it means that there's certain operations that require elevated privilege. So this is really tell the Ansible to say, for this particular play, I want to elevate my privilege to sudos or root and execute certain tasks. And gather facts is really meant to be able to collect informations, runtime information about the VMs that Ansible is connecting to, such as the VM might have what is the total memory size, and what is the used memory size, what is the operating system information, and those kind of things, because the Ansible playbook or jobs that you want to orchestrate might need to depend on certain information that's happening at that particular time. So serial is the one that's the most important part for this particular play. Serial 1 means for this play, I'm going to apply every task that you define in this play against all the hosts, but only running one host at a time and doing it serially. So if any host that when you try to apply a task, if that task failed, it will stop right there without impacting rest of the server. So it's fail fast, fail early. And serial, it's also the way of helping us to perform non-disruptive Gemfire operations. So we will still have a cluster highly available at all times. So for this particular play, we actually have two tasks. The first task is actually just install Gemfire. So this install Gemfire task really behind the scenes is install or update. If there's already existing Gemfire, it will just replace it. If it's a fresh VM, it will do a fresh install. And then after the task is actually being completed by the install or update Gemfire operations, then we want to confirm if, so this is when condition. This is like in the Ansible, you can actually do conditional operations. When certain conditions is true, then I'll perform certain operations, else it will just be skipped and ignored. So this is really saying, okay, I have some kind of variable or flag that confirms that I already installed or updated Gemfire binaries, so I want to perform rolling restart. So we can look at the task, the actual task itself. We can look at install Gemfire. So Ansible is the very first things we're going to try to do, so let me collapse those stuff, make it easy to read. So the very first things when we want to install Gemfire, we want to set up some kind of a global static variables. We're going to set up this global variable to say update Gemfire. Initial value, you're going to say true. So you're going to say, OK, it's true. But we actually want to verify if there's existing versions of the Gemfire that we care is already installed or not, right? So we actually want to verify it. So based on our previous definitions of where the Gemfire is actually being installed, so we're going to verify so this is the variable we'll actually concatenate the Gemfire name and the version number to form up the actual directory name. So this will actually go into OPT directory and to look very specific versions that we cared and to see if that's already installed or not. And we're going to register the result to say if we find that directory or not. And once we say, OK, we found the directory, it's existing Gemfire that we want to install or is actually there, then we're going to say, we're not going to update Gemfire. So we're going to say, you know what, the versions 9.1.1 is already there, so we're going to set this to false. We're not going to update it. However, if it's not there, even though there's Gemfire 9.1.0, but we cannot find 9.1.1, we're not going to change it. We're going to move on to the next block. So the next block will say, OK, update Gemfire is still true. I need to update Gemfire. So first of all, it will, again, try to locate existing Gemfire, but regardless of versions. It's not going to look for version 9.1.1. It's going to look for any Gemfire version is already there or not. And once we find it, we're going to uninstall it. So this is, all those are the Ansible out-of-box modules. It's very similar to the find command in Linux. And this one is very similar to identify the files and identify particular resources, whether it's file or directory, and to make sure that it's not actually available. So this is state, because Ansible is really about configuration management. A lot of command or a lot of module is state-based. So we're going to say if we actually found any existing Gemfire regardless of versions, we're going to uninstall it. Then we're going to download the actual Gemfire binaries from AWS 3 bucket based on the Gemfire version names and place into the temp directory. Then over here, we're going to unarchive it into the OPT directory based on our default setup. And then we're going to create symlinks and link it up, that Gemfire installation into OPT Gemfire, and then update the profile D. So we will be able to put Gemfire into the path. So then we can run gfish, just like what we did previously. So that's install Gemfire. And then we can look at the restart task, restart Gemfire basic. So this is a reusable module that we wrote that is capable of restarting a Gemfire for entire group, either for a locator group or a server group, or a single Gemfire node, or entire Gemfire cluster if you apply serial equal to 1. So this is basically rolling restart. So really, this is a reusable task that can be applied into different playbook or tasks. So this is very simple. We are using systemd. So behind the scenes, we want to make our VM, our Gemfire VM, to be as simple as possible. We try not to place a lot of script onto those Gemfire VMs. So really, we have the Linux servers set it up on those VMs. So a couple of the servers that we have over here, and this is actually a very important aspect of this particular demo, is we have servers for a locator. So these are locator servers. So as you can see, our locator is really just using gfish to do start locator and with the Gemfile options and Java arguments, which is available in here, and you can override it, you can change it if you want to. Then we'll also have the classic server servers. That's, sorry, classic servers, which using Gemfile start server and by passing additional options and Java argument. So this is the one that using the gfish to handle everything. However, for the boot app servers, it's actually using Java. So you just basically start a Spring Boot app by using Java directly so you can have server coming up. So once you have those servers to set up proper, really you don't need additional script to be deployed onto the VM. You can just use Ansible to do all kinds of orchestration outside the box. And VM by itself is really simple and very easy to either to monitor or to maintain or just to explore. So coming back to the restart Gemfire task. So this one is really we're going to have using the systemd, we're going to say what's the server host type we actually want to restart. So this is, we're going to say either it's Gemfire locator.servers and we want to restart it, or Gemfire server.servers we want to restart it. And those are the conditions that help us to make this particular task reusable based on different type of scenario. You want to start locator, or you want to start the server, and so on and so forth. And also when we start the server, once the server gets restarted, we want to make sure that the server is properly coming up before we actually move on to the next server. So this is one of the ways actually looking into a log file of the Gemfire server to ensure a certain hint is actually fully available in the log file before we can say, yeah, the server is probably coming up proper. So if we can, for the Spring Boot app, if we say start Gemfire boot application is present, or for the classic cluster, if we see cache server configuration is present, then we'll say, okay, we're good. We can get out of the waiting state, move on. However, if those logs never showed up, Ansible eventually will have some kind of default timeout over here, and it will time out, it will stop blocking, and then it will throw error, and Ansible will just error it out and will not without moving on to the next server. So this is starting the server, and actually the Gemfire update. So this is on the dev side. Sorry, for the operation perspective. So right now, the operation that we have is very simple. Doesn't have a lot of, it's not fully completed, because if you think about it right now, we only have operating system update, the Gemfire update, and also reprovisioning, clean out the Snowflake. Other stuff we can keep adding to those apps, automations such as backup and restore, import and exporting data, and those kind of things. So there's a lot of potential. We can continue to grow those use cases. So let's get on to the dev. So the dev pipeline, really the first job is build. The build is Maven build. It will run the Maven clean test build, create an artifact, push it into the Maven repository, and deploy server. We'll grab the actual artifact, and then we'll deploy to the server side and doing rolling restart. We're not going to dive into the deploy server because it's very similar to what Gemfire update. So, but we're going to look at the client deploy. So this is actually deploy the client applications onto the PCF, and because for the demo purpose, we actually have the application running on the PWS, Pivotal Web Service. So we actually have the application running over here. This is Swagger UI that we can actually verify to try something. For example, I want to put a customer into a customer region, so we're going to try it out to make sure the cluster connection is all good, and want to read it out. So as you can see, you can read it out, it's Jeff. So one thing we want to demonstrate is actually a blue-green deployment by using this pipeline. So now we can prove that Gemfire server side, we can do no downtime deployment. But how about the client? We want to ensure the client server deployment, the experience is consistent. So Gemfire server is highly available, same thing as our API, our servers. Once it's running, when we want to do the deployment, we want to make sure it's also consistently is highly available without downtime. So over here, I'm going to deploy the app. I'm going to run it. And so behind the scene, the concourse is going to do CF push. If you are familiar with the CF push output, this is really CF push behind the scene. So we can actually go into the web service, Pivotal Web Service, and look what is happening. So I need to log in here again. So the task app that we're interested in is, the application that we're interested in that's actually doing the deployment is task app client. Even though you see right now it said crashed, but as a matter of fact, it's doing the AB deployment right now. So I can make operation right now while it's doing the deployment. I can run without getting any exceptions and still be able to get data out. That's amazing. And why is that happening? So behind the scenes, Concourse is able to be able to remove the existing application or older version of application into a different application name without changing the route. So the route that we are having over here, this task app client-cfapp.io, still pointing to the older versions of the application running on PCF. But then at the same time, it will try to deploy a new application to the new name, but not enabling the route at that point in time until this app is fully up and running. And once the app is fully up and running, which you can verify over here because our concourse pipeline just completed without any error, it will actually replace, you will remove the old app and then change the route to the new versions of the app and only make a single version available. So that's A/B deployment, and without my application is not impacted. So you think, I just described a complicated flow. You have to rename the old app, keep the route, deploy a new app, and verify the route, and change it going back and forth. But it's very good that Concourse just handle that for you. So we can look at the Concourse. It's a very simple configuration on the Concourse. Deploy client. Again, input and output. Here is the push, CF push. You just need to define the current application name. Just this one-liner enables A/B deployment by using Concourse. It's really cool. So this is the very simple demonstration of client-side and app-side deployment using the pipeline. It's automations. Everything sounds good. Very nice. But for you to be able to have a confidence about the automation you just put into place, just be able to, some kind of script is doing things behind the scene for me, does not mean everything is actually running as intended in the actual environment after things get deployed. For you to have high confidence about all those automations, you need tests behind it. So without any tests, if I just have automation running behind it, I cannot sleep at night. I might get called 2 o'clock in the morning and say, hey, by the way, your pipeline just deployed something and break everything. So we want to make sure that pipeline have proper tests in place. So I'm going to hand stage over back to Anu, so Anu will be able to talk some of the testing strategy and how Gemfile can be tested. Thanks.
Thank you, Jeff. So let's talk about application testing. So typically, when you do your unit testing, you're running with mock. So why would it be different when you're doing your Gemfire deployment? So we'll talk about how we can mock our Gemfire functions and how we can do mock unit testing. When we work with databases, we use in-memory H2 database, and we run our integration test, unit integration test using this in-memory database. we are using Geode as our data. So why shouldn't we also do the same thing with Geode? So that's where we use the embedded Geode functionality, which can let us run those integration tests using the embedded Geode and get the same experience as you would do with any database. So let's look through the code. So yesterday, I don't know how many of you joined Anna's and Paul's talk. They did go through the function testing. It's not a repeat, so we have slightly different. So their testing was using Gemfire with Spring Data. So we are showcasing the classic cluster. So with that, we cannot use Spring Data because there's no Spring injection. The code gets deployed through the locator. So we are not using Spring for injecting data. So this unit testing is going to show how you can do it without using Spring injection and still use mock. Why would this not show up? It's not coming up. Represent something. Got it. Oh, is it? Okay. So I have a function which is going to calculate the total cost of the order. So I want to do a test on that. So let's go with starting with the test first. So I want to, so the function name is called customer order price function. So it's going to give you the total cost of that order. So we want to test it. So we're going to call the function and then test it whether it got the data correctly. So for that, I need to set up my data. So I'm going to create two mock regions. So I have the customer order region and the item. So order is where I'm going to store my order, but the order doesn't have any rate of that item. So the item region will have the list of the items and has the rate for the item. So we're going to set up, so we do the setup. So we set up, we add the items, put the information in there, set up the customer orders, and then we set up the regular mock the way we set up do our mocks. We can do that. Now, the question here is I have these mock regions created, but I don't have Spring to inject those regions in there. In Gemfire, to get a region, if I'm not using Spring injection, it uses static methods. So I really cannot mock those static methods. So what we are doing is we are using SPY. So that's a feature from Makito, which will help us work with the mock functions. We also wanted to see, make it easy. So how do I get access to the static? Like, I don't want to mock the cache. So I want to just mock my region. I don't want to mock the cache. The cache is the one that is static. So we said we'll create a separate region. So then SPY can help me saying that whenever the method is called, I can return the mock object. So that's why you see we have written get local region. So that's going to, so when that method gets called, it's going to return my mock region. And same thing for the item region. So let's go look at what the function looks like. So typically in a function, the method that gets called is execute. And you didn't see a test for that execute. So execute is the standard functionality of how a function gets executed through Gemfire. So Gemfire is already, as a product, that functionality is already tested. So it really doesn't make sense for me to write a unit test for that. Why write something, why test something which is already tested? So we are not going to test that one. We just want to test our business logic. So to make that easy, what we did is we separated that out as a separate method, so then we can test that method. So we have, so this function execution delegates it down to get customer order price, and that's what we are going to test. So here you see So it's getting the regions. Same thing, we don't have Spring injection, so we're calling the method called getLocalRegion, which is, if you look at it, so that's actually calling cache factory get instance get region. So that static call, we need to mark it, so we isolated it out into a separate method, so then we can use the spy to do that. So it gets the data. Now, why I'm getting data for the region? Why am I getting two different regions? Like I'm getting local region in one place, and then I'm looking at item region. So reason for that was when you looked at the execution of the function gets executed on all the servers if you don't specify which server you want to do it. So that's waste of time. If I'm going to just get a data for one customer order, why do I execute it on all the servers? So when I'm executing the server, the function, I can specify on the region, and I can specify for what I want to execute it for. So when it's actually running on that server, you don't want to go and look for that order item on all the servers. You want to just, because now I'm already on that server, I just want to get the order from that server. So I want to operate on the local data. So that's why for customer order region, I'm running on a local data. But then the order can have items from anywhere in my cluster. So they are not co-located because I can order whatever I like. I don't have to be confined to what's on that server. So for that one, that's why the other region is doing just a get region, and it's so based on the item name, it's going to go to whichever servers that is, and it's going to pull the data for that. So very straightforward. I'm able to run, mark it, and then let me just run the test so we know it works. Ideally, we would have liked to code it, but we didn't do that. We already have it, everything running, so we're just going to run it. No live demos. There you go. So it's nice and green. So that worked with Mark. Now I do have embedded Geode functionality, so let's use that, and let's see how we can test using that and write an integration test for that. So very similar to how my mock test was. I'm going to execute the function, and I want to assert that my data that I got back is what I was expecting. But now I am running in an embedded Gemfire, so I don't have a cluster, so I need to set up my Gemfire cluster. So I'm going to set that up, and it allows you to do that. So here I have a setup, which is setting up my Gemfire. I can set up my cache factory, set up my PDX serializer, create my cache server, create all my regions. So I have my Gemfire cluster created, embedded cluster created. Now I need to add data for it. So then I have separate methods which are setting up the data. So I have a customer order set up for 2 orders. So we wanted to do some additional testing, and then setting up of the items. So I do the setup of the data. And then that's it. I don't have to do. So this is like a straightforward, you would run an integration test. I'm going to run this one. Oh, there you go. For some reason, it did not switch to the GUnit test. So there you go. So we have all the tests running. Very good. So I have the integration test and the unit testing. So when I do my deployment, I have a good confidence in how that my code is good quality code, and I can deploy it on the server. So things that we did not show in this demo, which we can extend in the pipeline, is running smoke tests. So once I have it on the server environment, we can run smoke tests in that server environment. We can run performance tests, and that will take us to our next step, which is doing the continuous delivery. So once I start automating all those tests, I really don't need a human intervention. Everything goes through. I have a good confidence in my testing. I can just push it to production. That's what we had for testing. We talked about this. And here are some references that we talked about. So we use Concourse. So there's a reference to Concourse, Ansible, Terraform, and the Geode. And then this is a nice tutorial I found, which shows you how you set up the Gemfire cluster. And that's what we use to actually set up our demo. Because at HCSC, we are right now using Spring Boot. And we are in the process of switching it to a cluster configuration. It gives us a lot of advantages. If I am especially in the ops side, if I am running out of memory or something, I can just add a server and the configuration gets pushed out. So cluster configuration is really helpful in that case. So we're looking at moving into the cluster configuration. And so if you were not at Anna's talk yesterday, it will be on YouTube, so please look out for that. So we talked about building the APIs, so the whole configuration that we talked for the CI/CD. She talks about how we build those APIs. And then our VP, Mark Carito, is going to be on main stage talking about our cloud native initiative. And then Paul and Heather are going to talk about so we talked about how we build the APIs. We talked about how we do our CI/CD and automate the deployments for Geode. How do I get data? So that's what they are going to talk about. So how we did ETL using Spring Cloud Stream. They're going to talk about how we get data into Gemfire. Thank you.